Greetings, welcome back. This is N1IR. We're on part 11, Talk to Outer Space. Okay, so this is the first 10 sections we've gone over. Okay, so now we're on section 11, Talk to Outer Space. Any amateur holding technician class license or higher may make contact with an amateur station on the International Space Station using 2 meter and 70 centimeter band amateur frequencies. The initials LEO tells that the satellite is low Earth orbit. So there's a bunch of satellites up there that you can talk to. They operate very similar to like repeaters, and you can bounce a signal off of them, or you can talk to the International Space Station. They're on occasionally on amateur frequencies. The following is provided by satellite tracking programs. Maps to show real-time position, satellite tracking over the Earth, the time, the azimuth, and elevation at the start, maximum altitude at the end of the pass, the apparent frequency of the satellite transmission, including Doppler shift. All these choices are correct. So in a video in here, I'm going to show you how to get into the AMSAT Amateur Radio Satellite web page and track some satellites using their web application. So there's a bunch of software out there that you can get for free. You want to make sure the Kirplan elements are inputs to satellite tracking programs. So your K element, so your Kirplan elements, have got to be up to date to your satellites, because your satellites decay over time and they change. So computer programs websites show you where the amateur satellite space stations will be in range of your ham station, and they'll tell you the azimuth and elevation of start of signal and the loss of signal. And you can actually hook up your computer to a automatic azimuth and elevation rotor and have it adjust the antenna for you automatically, or you can go outside and manually use the antenna. I've had good luck with a 2 meter 70 centimeter beam antenna mounted on a camera tripod, and I just track it by hand, and it works pretty well. I just use an HT for that. A satellite beacon is the transmission from space stations that contain information about the satellite. So usually it'll be in a digital format, and it'll tell you things like the battery voltage, stuff about solar power, this common information like that. That's transmitted on a beacon, along with its call sign. The call sign will actually be in CW as well, or Morse code. Rotation of the satellite and its antennas cause spin fading when referred to satellite signals. With regards to satellite communications, observed changes in signal frequency causes relative motion between the satellite Earth station is called Doppler shift. So with Doppler shift, you can think of a car passing by you with the horn blaring, or if you stand next to a train as it's going by sounding its horn, you'll hear a pitch change as it passes you. It's a higher frequency as it approaches. The frequency when it's right next to you will sound at the correct frequency, and then when it goes away from you, it sounds lower. So it goes from a high pitch to the right pitch to a low pitch. And the same thing with RF. RF works exactly the same as sound with the Doppler effect. And you're going to constantly have to tune your radio as the satellite passes. So it's a combination. If you do this stuff by hand, it's a combination of adjusting your antenna, adjusting the right frequency, and you do this all in concert. It's kind of an interesting thing to do, and it requires a little bit of practice. When a satellite is operating in the UV mode, which means the satellite uplink is on the 70 centimeter band and the downlink is on the 2 meter band. And that's the thing with Doppler shift too. The higher the frequency, the smaller the shift's going to be as it passes. So that's why it has a UHF, VHF, UHF up, VHF down. So you'll see a less of a Doppler change on 70 centimeters than on the 2 meter band. And on the microwave bands, they're pretty much dead on. There's not too much of a Doppler shift on the microwave stuff. The minimum amount of power needed to complete contacts is the amount of power that should be used to uplink frequency of an amateur space station. So you want to use the minimum amount of power. Could be other stations contacting it. And don't forget that little 5-watt transmitter you're using for your HT, that satellite can hear it. You're really pinging it like crazy. So you don't need 50 watts. You don't need 100 watts. 5-10 watts will do fine to hit the satellite. FM packet is commonly used method of sending signals to and from a digital satellite. So part of the beacon could be packet. There's email servers on some satellites. You can bounce your email up and collect your email back. So the FCC Part 97 definition of telemetry is a one-way transmission of measurements at a distance from a measuring instrument. So telemetry is one way from the satellite, and it's of measurements at distance from measuring instrument. So it can send things like battery voltage, solar voltage, what frequency it's operating on. You can turn that sort of stuff. Just technical information coming down. The FCC Part 97 definition of telecommand is a one-way transmission to initiate, modify, terminate functions at a device at a distance. So you're controlling it one direction up to the satellite. You can turn it on, initiate it. Excuse me. And that is the end of this section right here. Talk to Outer Space, section 11. We're going to go on to the Q&A section next.